Okay, lesson 10. Quadratic polynomials, remainder theorem, synthetic division, rational roots theorem. A lot of different things to talk about here. Okay, so, a little bit of vocabulary here about quadratic polynomials. If you will notice, is the bug crawling around again?
Yeah, but okay. we're reading the Metamorphosis in English. So the guy turns into the bug and we're like, hey.
I think there's been a bug crawl. I think it must be just the same bug crawling around my room all day. I don't know.
He's kind of cute.
It's going under your foot.
Maybe it's like a family of bugs.
I don't know. That's the thing. I don't know if it's one bug or multiple bugs. Okay. Sorry. I'm just distracted as you guys are here. Okay. So some vocabulary. Quadratic polynomials, if you look across there, it's basically the same expression, x squared minus 3x plus 2, but there's listed quadratic polynomials, quadratic polynomial equation, and quadratic polynomial function. So quadratic is because the highest degree is x to the second, okay? Polynomial, that is multiple terms being added or subtracted together, okay? In those terms, they're just x to some power. The power can't be negative. You can't have x's in the denominator, that kind of thing. Now, this first one, it's a quadratic polynomial. It's just an expression, okay? This one, when you set it equal to 0, it's now an equation. And officially, when you make it y equals that, we can call it a function. Now, what do you know about x squared minus 3x plus 2? It's a polynomial, and it can factor? What's it factor into? X minus 1, x minus 2? So what do you know about if it factors into x minus 1 and x minus 2? What does that allow you to find? Zeros, right? Okay. And what are your zeros? 1 and 2. So over here, where by the quadratic polynomial, I'm going to call them zeros. Okay. Over here, what's an equation? I'm going to call them solutions or roots. The solutions or roots to the problem are 1 and 2. And that's when it's the equation equal to 0. Over on the function, well, where are these at on the graph? These are your x-intercepts. And so x-intercepts of 1 and 2. So it's really just about the vocabulary. When it asks you to find the zeros, the solutions, the roots, the x-intercepts, they're not technically all the same thing, but yet they are in a way. Okay? You know, I mean, solutions or roots, technically it has to be equal to 0 to have that happen. You know, it's x-intercepts, it's a function. But those are all really kind of words for finding the same type thing. Okay, so just be familiar with those words and kind of how they go together. A quadratic function, the shape of the graph is what? Parabola, right? What's a parabola look like? A U shape, right? And one form, I know we learned this last year in pre-cal, I think we did a little bit with it in Algebra 2, but one form of a quadratic function or quadratic equation is y equals a times x minus h squared plus k. And this is what we call vertex form. It's vertex form, if you recall, because h and k are right there staring at you. They're your vertex. Okay? A has to do with whether there's a min or a max and whether there's a stretch or a shrink. Okay? But this has to do with your vertex. So just kind of be familiar with vertex form. We're getting ready to use it, obviously. As opposed to standard form, which is the ax squared plus bx plus c. So, example 1 here says graph the parabola. there are several different ways we can do this, and I'm not talking just by plugging it in the calculator. Okay, how can we graph it by hand? As we look at it right now, negative 2x squared minus 8x minus 5, there's about one thing I can tell you about this parabola, and that is that it opens which way? It opens down. Other than that, I can't really tell you where this is positioned or, you know, a whole lot like that. Okay, so I think we're going to go the route of putting it in vertex form because that is an important skill we need to review. So, in order to put it in vertex form, first of all, well, let's see. Completing the square. Remember completing the square? Because if I put this in vertex form, I need it to be x minus h squared. So what is the first step to completing the square? Okay, yeah, we need it in the form, and just to generalize, I say x squared plus bx, right? Okay, and that when I say plus, that can be a positive or a negative, okay? But it's x squared plus bx. As I look at mine right now, do I have a 1x squared?
No.
No. And because this is set up as a function, I can't divide the negative 2 to the other side. So instead, we're going to factor out the negative 2. And when we factor out that negative 2, I'm just trying to get it off of the x terms. So I'm going to factor out that negative 2 from the x terms. So I'm going to have negative 2 in parentheses. What is that what remains when it factors out from the x terms? X squared plus 4x. Now, I'm going to leave a gap before I end my parentheses. Notice I only factored the negative 2 out of the x terms. The constant of 5 is going to land after the parentheses. And again, I'm setting myself up to be able to complete the square and to get it to vertex form. Now, do I have x squared plus bx? I do. I have x squared plus 4x. The negative 2 is my coefficient out front. We have this minus 5 out back. After you have x squared plus bx, how do I complete the square? B over 2, quantity squared. So what is my b here? B is 4. Now that I've factored that 2 out, b is 4. And so if we do 4 over 2 quantity squared, we get 4. What do I do with that 4? Okay. In an equation situation where we're working with both sides, we add it to both sides. In this case, I am going to add it inside the parenthesis and then subtract it outside the parentheses. Except it's not just a 4 I'm subtracting in this case, because this 4 here where I added 4 is being multiplied by negative 2. So here we're subtracting 4 times negative 2, if you will. If we had nothing factored out here, we would just add 4, subtract 4. We're multiplying by the negative 2 because it was factored out. Okay, let's rewrite this. The negative 2 just stays out front. The whole point of completing the square is what? Yeah. Parentheses squared, right? X squared would break up into x and x, or the square root of x squared is x. Multiplying to be 4, adding to be 4, 2 and 2, or just the square root of 4 is 2. Because that middle sign's a plus, we're going to use plus. Clean up the outside. We had minus 5 and minus 4 times negative 2. I might go with plus 3. Minus 5 and minus 4 times negative 2. So minus 5 minus 8. Or excuse me, minus 5 plus 8. So this right here, we have gotten it in vertex form. And vertex form gives me a point where, okay, I can kind of graph this now. I know some details. Let's write down some of those details. Can you tell me the vertex? Okay. -2, +3. You change the sign on the one coming out of the parenthesis, but not just the 3 that's at the end. If my vertex is -2, 3, what is my axis of symmetry? Of course, officially, I should say x equals -2, because it's an equation of a line. And we've already talked about this, the fact that this opens where? It opens down. It opens down because that a value out front is negative. Okay, so when I graph this, I have my axis of symmetry, I have my vertex, I know it opens down. I always encourage you to get one other point. Stretch by a factor of 2. Okay. What's another good point we could use here? That's the vertex. What's an easy number to plug in? 0. And by plugging in 0 for x, that's going to give me my y-intercept. So the y-intercept is always an easy point to get. So if I plug in 0, and you could plug in 0 to your vertex form, you could plug in 0 to your original standard form. If I plug in 0, what am I going to get? -5. It's obvious up here. And down here, 0 plus 2 is 0, squared is 4, -8 plus 3, -5. Okay, so I'm going to scoot this over and I am going to just kind of sketch a graph real quick. Work on finishing graphing that real quick. You girls have your pink papers. Let's see. You scoot one seat back. Yep. Do the social distance thing. Huh? No, you're fine. If someone sits behind you, they're not social distance. So, you know. Let's see. Megan, I've already seen your review worksheet, right? Yeah. Gracie, have I seen yours? No.
I've seen it to me.
Okay, then I've seen it. If you sent it to me, I've seen it. So. If I've already seen the review worksheet, I don't have to see it. I don't have to see it. So, because they'll just eventually get passed back to you anyway. So, you're welcome. Pink papers and calculators. Okay. Did you guys graph this without me? Let's see. Officially, axis of symmetry, x equals -2. So when we fill in that axis of symmetry, dotted line. My vertex of -2, 3 means I'm going to go left 2, up 3, and done correctly, this should land on your axis of symmetry, right? If it doesn't, you're not doing something right. And we know it opens down. Does a point or a y-intercept of 0, -5 make sense there? It does. And if 0, -5 is there on the right, we have an equivalent point on the left. This one was 2 to the right, so I need an equivalent point 2 to the left. Not perfect, but something like that. Okay. Okay, moving on. Example 2. Find the quadratic function whose x-intercepts are -3, 2, and whose y-intercept is +3.
Okay, so is this the one where we take like boil those two together so you get that, and then, I don't know if you y-intercept, but is that what you do?
Okay, that's going to be part of my start. So the fact here, if we go with the idea that these x-intercepts, these are like zeros, aren't they? And they come from the parentheses of x plus 3 and x minus 2, right? And when you multiply those together, yes, you would get it to standard form. But here's the deal. Is there an a value? And this is where there might be an a value, right? We don't know. And so what I'm going to write this as right now is y equals a, because I don't know, is this right side up? Is it upside down? Is there a stretch? Is there a shrink? I don't know just by looking at those points right offhand. So the equation I'm going to set up then, using that x plus 3 and x minus 2, is that. How does the y-intercept help me here?
It means to the end of that equation,
No. What's an ordered pair for a y-intercept? A y-intercept of 3, that is. This is going to be the ordered pair, 0, 3. We can use this ordered pair of 0, 3 to plug it in for x and y, and then that gives us a way to find our a value. And then we'll know right side up, upside down, stretch, shrink, all of that. So if that's the case, y is 3 equals a times 0 plus 3 times 0 minus 2. Then I have 3 equals a times 3 times negative 2. Negative 6a equals 3. Divide by negative 6, and a is negative 1/2. Because 3 divided by negative 6. Now can we write an equation? Yeah, now we have the information to write an equation. Two different ways we could easily write it. The easiest way would be y equals your a value out front of negative 1/2 times x plus 3 times x minus 2. Could you go a step farther if expected? How talented are we with mental math? And I'm going to have both of these boxed as possible answers. Like this one is a possible answer. And then I'm going to say or. Can you FOIL and then also multiply by negative 1/2 all in your heads? Okay, well, x times x, x squared. If I go ahead and multiply by negative 1/2, that's going to be negative 1/2 x squared, right? Now do your outsides, insides. Outsides and insides are going to be 3x and negative 2x, which is 1x, times the negative 1/2 is going to be minus 1/2 x. And then lastly, 3 times negative 2, negative 6, times the negative 1/2, plus 3. That's something you guys would do on your own, possibly. Maybe not, but some of you would, I know. Some of you are looking at me like, oof, that was too much of a stretch.
So now you said only AP Calculus, and that is, you don't have to like fully simplify it. So you think the calculus will be fine?
It would come down to, I mean, they're not just gonna, well, I guess it depends what they have you doing, but unless they specify a form, as long as it's equivalent. Okay, so kind of like when you write an equation in line, unless they specify a form, as long as it's equivalent is what matters. Okay? Okay, moving along. Remainder theorem. Okay. There's two different ways to do remainder theorem, and you guys like this one. You've been doing this one since Algebra 2, technically. When a polynomial, f of x, is divided by x minus c, so like the binomial x minus c, where c is some constant number, the remainder equals the value of the polynomial evaluated at c. In other words, f of c is the remainder when f of x is divided by x minus c. Now, that's all the fancy words, right? My example here says, what is the remainder when this polynomial is divided by x plus 2? I'm going to go the way that honestly probably is not what you would likely do. But notice they talked about the remainder equals the value of the polynomial evaluated at c. So if my polynomial here is f of x equals x cubed plus x squared minus x plus 1, they give me the binomial x plus 2. What do I use as my c value that I'm going to plug in? It would be negative 2, right? And so one way you can find the remainder is to plug in negative 2. Do f of negative 2 and plug it in. I'll be honest, this is probably the least favorite way. I know this is not necessarily the way I do it. Okay, because sometimes the math can get big real quick, can't it? Which is why this is not necessarily the way I would do it, but it's not horrible here. Negative 2 to the third, negative 8, plus 4, plus 2, plus 1. So f of negative 2 is negative 1. And what is that negative 1? That is the remainder. Okay, if you were to divide these polynomials, that would be the remainder. What's the other way you could have found the remainder? Synthetic division. And we're going to practice synthetic division in the next section, so I'm not going to practice it here. But could you legitimately use synthetic division here? Yes, you can. And I am perfectly fine with that. Because as I said, honestly, we had a number bigger than 2. This was going to get real big numbers real quick, wasn't it? So that's my preference of synthetic division. It doesn't get as bad as quickly, I don't feel like. So, okay. Speaking of synthetic division, we reviewed this briefly at some other point, didn't we? Like back in lesson 1 or something, it came up. So, use synthetic division to divide p of x by x plus 1. Okay, so officially, it says we're dividing. Okay. What goes in my box? Well, so if I just put in a number, because it's x plus 1, use, the 0 of that, negative 1. What numbers go in that top row? 2, 3, negative 4, negative 7. Check. Make sure we have all the powers covered, right? If there's a missing power, put a 0. Okay, you remember what to do here, right? Drop the 2, and then multiply. Negative 1 times 2, negative 2. 3 plus negative 2, 1. Multiply. Negative 1 times 1, negative 1. Add. Negative 4 plus negative 1, negative 5. Multiply. Negative 1 times negative 5, 5. Negative 7 plus 5, negative 2. Now, it didn't specifically just ask for the remainder, but what would the remainder be? Negative 2. But it said to divide this. So how do I express this answer of 2, 1, negative 5, negative 2? Okay, exactly. So we start one less power than what, because we divided, we're 1 power down, so 2x squared plus 1x minus 5. And normally we would say plus something over the divisor. Since it was a negative remainder, I went ahead and said minus 2 over x plus 1. And that x plus 1 was the divisor. Okay. Directions are slightly different on example 5. It says use synthetic division to evaluate 3x to the third minus 4x minus 2 when x equals 2. Okay? Evaluate is more just a different way of expressing this, kind of in a factored form, and then plus the remainder. Now, we're going to start with synthetic division. It'll just be a difference of how we express our answer. What goes in the box this time? 2. Because it says x equals 2, we're using 2. Okay? What goes next to the 2? You can just lay it here on my desk. 3. We need a 0 because we're missing x squared. Negative 4, negative 2. I'm assuming this is coming back and you guys are going to ask questions if you have them, right? Okay. Drop the 3. 2 times 3 is 6. 0 plus 6 is 6. 2 times 6 is 12. Negative 4 plus 12 is 8. 2 times 8 is 16. Negative 2 plus 16 is 14. Okay. Thank you, girls. See you pretty soon. Okay, so we know that 3, 6, and 8 represent the answer, correct? So how do I express that? Okay, and we're going to stop there, okay? That, and we divided by x equals 2, so to speak, right? What is x equals 2 as a 0? But as the 0, I guess as the factor, wrong wording. As the factor, x minus 2, right? So we really took this and we divided by the factor, x minus 2. And then what remainder did we have? A positive 14. So let me explain what I wrote down here, because I decided it'd just be easier to write it down and then make it make sense. Okay, so what we're saying here is that this original problem of 3x cubed minus 4x minus 2 can be found by taking our answer times the factor we divided by, adding the remainder. So this is a factored form plus a remainder is what you're looking at. Okay? And we use this because they said to use 2. Okay? And that's just based on the fact of evaluate. It's a way synthetic division can help us to, rewrite problems. Did you see all the connections there? Okay. Gracie and Megan, are you guys study hall or aides? Okay. Do your people know where you're at? Yours does not. Because you came during lunch. You aid, so I don't know if it matters as much. But who do you have for study hall? You might go tell her because she'll mark you absent pretty quickly. And she doesn't usually go back and fix them, I don't feel like. So, yeah. Gracie, do you aid in the office?
Yeah.
Okay.
I leave in Alley, so they know.
They'll tell them. Okay. Okay. Closed the door, didn't she? Okay. Rational roots theorem. Okay. Ross said something over something last time, and rational roots theorem. If a polynomial whose coefficients are integers has a rational root, then the number is a fraction whose numerator is some integral factor of the constant term and whose denominator is some integral factor of the term of highest degree. AKA, we're talking about the last term and the first term, right? So the constant being the number at the end. The other one is the coefficient of the highest degree. So, thus for this example here, the rational roots can be found by forming all fractions whose numerators are factors of 3 and whose denominators are factors of 4. Okay? Ross said C over B. I honestly don't remember.
I said C over A.
Oh, C over A. I honestly don't remember right now. It's not coming to my head of what letters I taught it with. So, whatever it was, C over A, sure. Anyways, factors of 3 over factors of 4. We can look it up later. Okay, so example 6 says to find the zeros of the function. And the idea here is you're doing this without a graph, right? We're not cheating and going and looking at the graph because that would tell us what any zeros are. Thank you, Kaylee. So we're going to start, and I usually said we called them PRRs, possible rational roots, or potential rational roots, depending on the terminology. In this case, we're doing factors of what on top? Okay. And I just say factors of 4 because we're going to use plus or minus. So it doesn't really matter. Over factors of what on bottom? Factors of 1. So they're making life easy on us. And that's because 1 is the coefficient of x cubed. So what are factors of 4? Okay, so I'm going to say plus or minus 1, plus or minus 2, and plus or minus 4. Because 1 times 4 and 2 times 2. Factors of 1? It's just 1. Okay? So we like it when this happens because, remember, I usually go through and write them out so we know what they are. But if they're all over 1, it's just easy to say, okay, my possible rational roots are plus or minus 1, plus or minus 2, and plus or minus 4. So at most we have 6 possible things to try. Okay? So, how do we try them?
Yeah, because if they're actually zeros, you plug them in.
Mm-hmm. Okay. Ross said plug them in. I prefer to use synthetic division. Now, and I get it, when you plug in 1, negative 1, when it's small numbers, it's fine. But I usually use synthetic division. If you want to plug them in, the deal is we're looking for a remainder of 0. Whatever makes you happy there, right? So, if I start by using 1, then what's going to go on that top row is 1, 2, negative 2, and 4. And do your synthetic division real quick. I know sometimes in pre-cal we'd check the calculator, wouldn't we? But I'm trying to avoid that here, so. Oh my gosh, what did I do? Okay. Sorry. So on that top row should be 1, 2, negative 2, and negative 4. If I said that wrong out loud, then you might be goofed up. So when I do my synthetic division, I just got a remainder of negative 3. Is that what you guys got? Sorry, I made a mistake the first time through. So what do we know about that one? It's not that one. Okay? Yep. Nope.
Thank you.
You're quite welcome to it. Okay, so what do I do now? Try the next one. Okay, try negative 1. 1, 2, negative 2, negative 4. So drop the 1, multiply, add. Multiply, add. Multiply, add. This time I got a remainder of negative 1, so guess what? That one doesn't work either. Now we're going to try 2. Drop the 1, multiply. 2 plus 2 is 4. Multiply. I got a remainder of 8. So what do we know? Still not working. So now what? Keep going. Hey, we've tried half of them. It's got to work at some point. Negative 2. 1, 2, -2, -4. Drop the 1. -2 times 1 is -2. 2 plus -2 is 0. -2 times -2 is 4. -2 plus 4 is 2. -2 times 2 is... where did I make my mistake? Oh, dang it. Don't follow my lead. Don't. It's bad. Oh my goodness. Just do your own thing, okay? Meet me in the end. When I'm wrong, I'll go back and fix. Okay, -2 times 0 was 0. -2 plus 0 is -2. -2 and -2 is +4. -4 plus 4 is 0. And all of that to say, this one works, doesn't it? Okay, so with that in mind, they asked us to find the zeros. So one of my zeros is -2. Now, with that in mind, since that 0 is -2, that can also be written as a factor, as x plus 2. What is my other remaining factor right here? What does 1, 0, -2 represent? Okay. X squared minus 2. And so officially what I've just done is I used synthetic division and I factored it, right? I have a factor of x plus 2, which we already know that when you set that equal to 0, we're going to have a 0 of -2. What about x squared minus 2?
Can't we then use that as our dividing?
You could, if you know there's more rational roots. Here's the deal. There may be more rational roots. They may be irrational roots at this point. We don't know for sure. So you could keep going and try the others. But if this is something that is factorable or solvable, you want to just forget synthetic division and factor or solve it. X squared minus 2, I can solve. And I'm going to tell you, these are going to be irrational roots. So you wouldn't get anything out of trying all the rest of the numbers. Okay? So if I do x squared minus 2 equals 0, what happens? X squared is 2, and so then x is equal to what? He fixed it. Plus or minus the square root of 2? So when they asked me for zeros, how many zeros did I come up with? 3 technically? As I should. It's an x to the third power, right? So my zeros are x equals -2, positive square root of 2, and negative square root of 2. And that's something exactly like what we would have done in pre-calc last year. Okay, we definitely did that. Maybe, I don't know how much of that we did in Algebra 2, but we did a little bit.
We did a lot. That was part of one of our tests. We had like a lot.
In Algebra 2 for you? Or in pre-cal?
Probably in Algebra 2 towards the end.
Okay.
And in pre-cal last year too.
Yeah, because we definitely did it in pre-cal last year. Algebra 2, I know I teach it some, so. Question, Ethan? Where the x squared minus 2 came from?
Well, I know where it came from, but I just didn't know why.
So once we get a remainder of 0, this means that this -2 we're using here represents a factor x plus 2. So that means that this factors. One of the parentheses will be x plus 2, and then the other parenthesis will be whatever this is. In this case, it was represented 1, 0 represents x squared minus 2. And the whole point is, okay, we're starting to get it factored. If we can continue to factor it more, like if x squared minus 2 factored, we could have factored that. Okay, it doesn't factor. However, it gave me the option if I could set equal to 0 then, because two things multiplying to equal 0, you take turns setting them each equal to 0 to find those solutions, and it allowed me to find the other solutions. Okay. In this case, it was easy to solve. Had there been a b term and it couldn't factor, you might have had to think quadratic formula. You know, that pops its head in there on occasion. Does that answer the question now? Okay. Okay, example 7. Find the roots. I'm looking at this and trying to, I must have just shortcutted it last year because we were running short on time. Because I just have one root working and went from there. Okay, officially, and we are getting close on time, so I am probably going to go ahead and shortcut. Officially, could we do the same process we did up there? PRRs, right? In this case, it would be PRRs of factors of 6 over 1, which basically means then 1, 2, 3, and 6. Okay. Can you eyeball which one works pretty quickly? I don't know if you can or not. Huh? 1 doesn't work, but -1 works. So I'm just going to throw -1 in there so we can find -1. Now notice this time it does say find the roots, but that's just another way to do the same thing. What will go next to -1 here? 1, 0, -7, -6. And really I want to look at, once we get this remainder of 0, how we can go about it. Thank you, Megan. Drop the 1. -1 times 1 is -1. Add -1. Multiply +1. Add -6. Multiply +6. Add 0. So what just happened? We found a 0, yes? So we know that one of our factors, -1, represents the factor of what? X plus 1. What does 1, -1, and -6 represent?
X squared.
Okay, x squared minus x minus 6. What do you know about the factor of x squared minus x minus 6?
It'd be x minus 3x plus 2.
Yeah, it factors, doesn't it? X minus 3, x plus 2. Last time it didn't factor, right? This time it factors. And that's good news. Because since that factors, we can just go ahead and say, what are our roots, or in other words, our solutions? -1, 3, and -2. So much nicer when it factors, right? And there's always that possibility of like quadratic formula. Okay? Okay. Example 8. Let's talk about this one real quick. What's the question ask? Not just rational roots, though. Possible rational roots.
That's what that is.
That just wants to list the PRs. Okay? Thank you. So what are we going to do? Factors of what on top?
3.
3. What are factors of 3? 1 and 3. Factors of what on bottom?
2.
And what are factors of 2? 1 and 2. Now, do not leave it like this when I ask for a list of possible rational roots. Go through and give me all the specifics. Do you understand what I'm saying there? So in other words, take turns putting everything over 1, takes turns putting everything over 2. So 1 over 1 represents 1. 3 over 1, 3. And then I'm going to put everything over 2. 1 over 2, 1/2. 3 over 2, 3/2. And I didn't say them, but what did I put in front of all of them? Plus or minus. Sorry, that was just kind of a given that I was just, again, trying to save time. Okay, so do watch when they just want possible rational roots. Okay. Example 9 says use a graphing calculator to estimate the zeros of the function x cubed plus 2x squared minus 2x minus 4. And that says check with example 10.6. So this is going to be the short way, isn't it? So you guys know how to graph, right? Sorry, we're at that time of year where I get in the habit of, okay, pre-calc, I can't just assume anything. You know, like you guys a year ago. I can't just assume everything. So I typed it in. I'm going to do a zoom 6, a Z standard, just to see what it looks like. Okay. What can you tell about this? Looks like there's 3. Are you 100% sure? I mean, okay. And so my reasoning for asking that is, I taught a way to zoom last year. I like ZBox here, which if you go into the zoom menu, ZBox is number 1. And why ZBox? Yeah. If you set this to zoom, and honestly, we really only need to see those 2, don't we? But if I even want to go ahead and get that 3rd over there, you know, set up your box however you want. But the idea is, can I verify? You know, can I make it so Jacob's not second guessing based on what I say? Okay, so I like ZBox. How do we find our zeros? Second calc 0. You remember how to do that? Lordy, where am I? Okay. If I'm going to save my time, I'll tell you that left one is -2. If I go for the second one here, -1.414. Does that ring a bell? Which is the square root of 2. And isn't that one of the ones we had up above? Yeah. And if I do the next one over, second calc 0, guess what I'm going to get? Yep. Nope, there it goes. So left bound, right bound, and now I have positive 1.4142, which is square root of 2. Or square root of, yeah. So, I like ZBox on this one, and then old news, I did second calc and used my 0 to find them, right? So x is approximately -2, -1.4142, and positive 1.4142. It said to check with example 6. Well, guess what? Example 6 was -2, negative square root of 2, and positive square root of 2. So did it match up? It does. Okay, so that is where the calculator is at a disadvantage. It won't tell you it's square root of 2. It won't tell you if it's something that could be written in, you know, a different form. Okay. Problem set 10 is homework.